recording this. And I'm going to share. Okay. Oops, that's not what I want to share. Just a minute. Stop sharing. Share. Okay, so can you see my screen?
Yes.
Okay, so we're going to review all the homework, chapter 5, 6, 7, and 8. Or, yeah, 5, 6, 7, and 8. There's a lot of stuff there.
Yeah.
And I apologize for cramming it all into one day. I think today is short and Wednesday is short. So we'll have time to sort of review some of this stuff, and we need to review some of it too prior to the quiz. So anyway, I apologize for that, but it's really important to do your homework only because that's how you're going to learn. You have to practice, practice, practice. It's the only way. Even though I'm not grading that homework, you need to do it, okay? Or for your own benefit, or you know, you're not going to grasp all these things because there's a lot of information, I realize, that thrown at you. Anyway, so we'll review the homework first, then we'll lecture. And today it's only on lesson 9 and 10, simplifying polynomials and adding and subtracting. Hopefully it's a relatively easy concept and to go through it. We'll have some lab problem solving on some of this stuff. And then we'll have our quiz, and the quiz covers lesson 1 through 8 in chapter 5. So there's a lot of stuff there, okay? The quiz and the quiz ends up being 28 points. I added up everything. There's a lot of things on that quiz. Most of them are very simple little answers, so I'll give you plenty of time, but I'm just saying it covers a broad area. It covers a broad area. So I apologize for I'm hearing feedback on myself. I'm hearing feedback. I don't know how to get rid of that, so please bear with me. Anyway, let's talk about any problems you had in lesson 5, 6, 7, or 8. Anyone want to give me one that we can look at?
Ooh.
One that you maybe got the answer, but you don't, because you looked in the back of the book, but you don't really understand it.
There was one. I don't know if I figured it out or not. I'm gonna find it here. I did have one, but I gotta find it.
Okay, well, go ahead and find it, Jessica. No problem. Anybody else have one that while we're still waiting?
I think I actually got it. Actually, I think I fixed it this morning.
Okay.
There was a lot of crap.
I know.
I mean, it was fun crap, but it was a lot of work.
I know.
I started to see double.
What do you see double? Well, that's not
Yep.
good. Sorry.
Which one was it?
Kathy, did you have any on 5, 6, 7, and 8? You're on mute. I'm sorry. You're on mute. Oh, you're still on mute.
Okay. I didn't get all through the homework. We had 2 deaths in our family, so
Oh, I'm sorry.
that was unbelievable.
Oh, well, I'm very sorry for that. Well,
Thanks.
yeah, I'm sorry.
My condolences too.
Thank you.
Definitely.
That's so hard.
Unexpected for sure.
Yeah.
Oh yeah.
That's the worst kind for sure. I'm so sorry. Well, anybody else have a problem? If not, we'll just go on to the lecture, but there's a lot of stuff there. So 5, 6, 7, and 8.
I guess not at the moment. I think I fixed it
Okay.
this morning. We're going over the notes, so.
All righty. Well, then, having said that, let's go to chapter 5, lesson 9 and 10 then, okay? So I'm gonna stop sharing. And share 6. Share that. Okay. So can you see my lesson 9, simplifying polynomials?
Oh,
Okay. So polynomials are broken down by terms, right? You got to understand what a term is. A term is a variable that has a unique power raised to it. In other words, like x squared, that would be a term. X to the third power would be a different term, right? It wouldn't be the same term. Give some examples. 8x cubed and 4x cubed are like terms because they have x to the third power, right? It's the same power. So you just add the coefficients, the 8 and 4 together, if you're adding them, and you'd get 12x cubed, right? 5y and 3y would also be similar terms. You can add the 5 to the 3 and get 8y, okay? But then there's unlike terms. Unlike terms are variables with different powers raised to them, like 9x and 7x squared are unlike terms. You can't add those or you can't subtract them. You can multiply them or divide them, but you can't add or subtract. Okay. So you can only combine like terms when simplifying polynomials, in other words, adding them. For example, the polynomial 7x squared and 4x cubed, you cannot combine because they're not like terms, right? Okay. If you have like terms like 7x squared and 4x squared, you could combine those, or you could subtract one from the other. It doesn't matter. I mean, you could do either operation, right? If you had an example, 7x squared plus 4x squared would be 11x squared. You just add the coefficients. Okay. Really important to understand this concept. So you can either add or subtract like terms. You can do either.
so really, like when you take the 7x2 plus the
Mhm.
4x2,
Yeah.
the twos don't really matter. They're just
Well, they're
there.
squared. Yeah, I mean they're the same. So the 7x squared and 4x squared are like terms because x squared and x squared on both of them, right? So you can
Mhm.
add those, you can add the coefficients. You can add the 7 and the 4 together and get
Right.
11x squared,
Okay.
right? Or you could also subtract them. If it was 7x squared minus 4x squared, it would be 3x squared, right?
Okay.
Okay.
Right.
So it's x squared or x to the second power. That's how you would name that, Kathy. Okay.
Okay.
You wouldn't say 7x2, okay, but you would say either squared or the second power,
Okay.
okay? And then down here, like 4x cubed, or you could say 4y cubed or 4y to the third power.
Okay.
You would name those. And you can see if it's like terms, you can add them. So you got a 4 plus 2, that's 6, minus 7 is a minus 1. So it'd be minus y cubed for that top one if you're adding those together. Right? Now, this one down here, you can't, oh, sorry, that's a 2x cubed.
Mhm.
It's not a y, so you just add the y cubed together, right? So it'd be
So you
4y
wouldn't.
cubed minus 7y cubed would be minus 3y cubed.
Okay.
And then you still have the 2x cubed, okay? In other words, combine it down here, okay? And then we talk about similar polynomials with like or unlike terms and simplifying them. And so what you have to do is you got to find all your like terms together and you can add them all up. And then you find, like in this particular, you got 4x cubed, you got another x cubed. So you can add the 7x, or excuse me, 7x4 to the fourth power and x to the fourth power. So that'd be 8x to the fourth power. Then you look at, you've got x squared, you've got an x squared here and one there. You can add those two together. So it'd be minus 11x squared. And then you've got a 5x and you've got an x, so that would be 6x. And you've got a constant 3, which is all by itself, so it's just plus 3. That's how you would simplify that, right? You add the like term.
So the 5x plus the x is going to add one more, and that's
Yeah,
why you
yeah.
got 6.
Yeah, because the x is one by
Okay.
itself, right?
Right.
And when you do these, I'm gonna write this down here. I want to go to the board to make it, just show you how to do it simply. Plus x. Okay, so I'm gonna share. I'm sharing that. Share. Boom. So now can you see my paint board?
Since I moved this
Yeah.
up.
My little carrots are the the powers, right? Because I
Yeah.
can't do that on this. I probably could if I could figure it out, but I didn't figure it out. Doesn't matter if it's not exactly the same thing in the book, because I just want to show you a simple way of doing it. But it's going to be different. So this is what this is, and so you're asked to simplify this polynomial, right? So you'll look, and now I'm going to use my little pencil here. You combine the like terms. This one and this one's going to combine, right? I don't have another one with that, so I'm going to combine these two. And so then you're going to write the x to the 4th power, and do this. So what's 7x to the 4th power plus x to the 4th power? What would that be?
8
Yeah, 8x.
x to the 4th.
Yep, yep. Okay, that takes care of that one. You've got a minus 13x squared all by, there's nothing else in there, so you're just going to leave that, and you say, well, it's minus 13x to the 2nd power, right? So now we've taken care of this one. Now we've got a 5x and a 1x, and what's that equal to?
6
That'd be 6x, right?
x.
And then what you've got left over, you've got a constant 3. So this expression simplifies to 8x to the 4th minus 13x squared plus 6x plus 3. You can't simplify it any more than that. Excuse me, I can factor it, but I'm not going to factor it. This is a simplified form at this point. Okay? That's how you do all these. You just take a pencil and mark the ones up that are similar, and then go ahead and add them up. If you do it like this, chances of making a mistake are a lot minimal. Okay? Than trying to do it all without sort of carving it up like I have. Okay, does that make sense?
Yeah.
That's what I would recommend you do those. Okay, stop sharing. And we're gonna go back to this page. And that's what these are. Okay, that's what we've done in those examples, just like I've done. So I'm gonna go on to the next page. And okay, sharing. And here. Okay, the next page looks like this. Okay, so the first drill is figuring out what are like terms. So is 4x cubed and x cubed, are they like terms, yes or no?
Yes.
Yes, right? So they are like terms, right? What about number 2?
Yes.
Yes. Okay, what about number 3? Somebody else give me an answer. What do you think on that one?
They're not like terms.
They're not like terms, exactly, because one is to the power of 1 and one is to the power of 2, right? What about number 4?
No.
No.
No, right? Because one's x and one's a y. What about number 5?
Yes.
Yes, right? What about number 6?
No.
No, right? What about number 7?
Yes.
Well, think about it.
What does the high mean?
Well, you've got g to the second power, and then you've got g to the second power times h times I.
Oh,
They're
no,
other variables,
because
so they're
it's
not like terms, right?
Yep.
Okay, what about number 8?
No.
What is it?
Yes.
It's
Yeah.
yes,
Oh,
right?
yeah.
Right?
can't-
Because you've got x squared and you've got a y in both of these terms. What about number 9?
No.
No, right? What about number 10?
No.
No, right? Because you got x squared here and you got an x there and you got a y and then a y squared there. So no. Okay, so yeah, I think you all get it how to do this, right? What about number 15?
No.
No, right? Because you got two variables, a and a b. Okay, so okay, enough of that. Okay, now simplify each expression by combining the terms. Look at number 21. What would that be?
Three X, oh, yeah, it'd be 7 X
One.
squared times Y.
Yeah, exactly, right? Because they're the same term, right? You got x squared and y in both of those. You're just adding the coefficients is all you're doing, right? And what about number 22?
Yes,
And what would that be simplified?
4B.
4b, right? Exactly. What about 23?
That one would be 6 minus 6.
Minus 6a plus 3, right?
Mm-hmm.
Right? What about number 24?
Be 16B plus AB squared plus 3.
Right, so it'd be 16ab plus ab squared plus 3, exactly. Let's look at 28 together, see if we can get this. What's the first term going to be?
G squared.
So it's going to be 2g squared, right?
Mm-hmm.
And then the second term would be what?
H squared.
H2 plus H2.
Plus 2h squared, right?
Right.
Because you got two of them, right?
Right.
Okay, so it's 2h squared. Okay, and then what do you got left? You've got minus 4g squared h squared, right?
Mm-hmm.
So that would be a term all by itself. And then you've got the constant of minus 4. So you're combining the g squares, the h squares, and then you're adding those the two other unlike terms, right? That's how you do all these, okay? They're not that hard. You just don't make a mistake when you do them. Let me see here. 8 squared minus 4x plus 7 plus 4x cubed. Just a minute. Minus x squared plus 7x minus 2. Okay, I'm going to share. I'm going to do number 33 or something like it if I copied it down. Close enough, I think. Okay. Look at my screen. New. So the first thing you've got is 8x squared minus 4x. Yeah, I'm sort of making this up here. I can't read my own writing, so this is going to be a problem. 4x cubed, 4x cubed plus x squared plus 7. Some of these can get really long, you know. I'm just going to add a few more here. Okay, so look at this guy here. Okay, so first thing you go through is you add like terms, right? Let's identify the like terms. This 8 will go with that, right?
Mhm.
The 4x, this one, we'll go with the 7x, right? This will be by itself. Then the constants, you've got this one, this one, this one, and this one, right? So we've identified all the terms. Now it's just a matter of adding them up, right?
Mhm.
So 8x squared and x squared is going to be what?
9x squared.
9x squared, right? And then the second one, you've got a minus 4x and the 7x, and what's that equal to?
Let's see, 3x.
Plus 3x, right? And then let's put this one down, this 4x cubed, that's all by itself, right? Yeah. You leave the constants till last, okay? That's why I'm doing it like this. And then you've got a 7, a minus 2, a 5, and a minus 2. And what's that equal to? What would that be? 7 minus 2 plus 5 minus 2. Somebody tell me what that is.
God, I want to say -2.
What is it?
13? Wait, that's wrong. I wrote it down.
You know, 12, okay. I have to do it myself.
Maybe 13?
Here, do it this way. Just add the 7 and the 5 together. They're both plus, right? So that's 12. And you've got two negative 2s. That's -4. 12 -4 is 8.
8.
8, right? So 8's the answer. It's figure a simple little way of doing it. I mean, that's what I did. Added the positive signs and then added the negative signs and then subtract the negative from positive. So you end up with this, okay? So this is a simplification of that, right? These won't get any harder than that. They're probably all like that. Something like this will be on your quiz, of course, for next week. We'll stop sharing. I'm going to go back to this. And that's what that's all about. So let's do 37. When simplified, how many terms are in the polynomial j squared plus k to the third power minus 2j to the third power plus 5k cubed minus 2j squared? So how many like terms are in this polynomial here? What do we got?
Is it 3?
Well, you've got the j squared, that's one. K cubed is another one. And yeah, and it's j cubed is another one. So you've got 3, right? So it'd be b, right?
Yep.
Okay, so that's how you do that. So let's stop. Let's move on to the next subject, next section.
Oh,
Actually, it's adding and so now we're adding and subtracting these guys, right? But just remember, you can only add the like terms. You can't add unlike terms or subtract unlike terms. So you've got this polynomial here, 3x squared plus x plus 4, and we're adding it to this polynomial, 2x squared plus 2x minus 16. So just put them all in a row and then start adding them up, add the like terms. You've got an 3x squared, you've got a 2x squared, right? So that's 5x squared, they show it right there. Then add the x, you got a plus x and a plus 2x, that's 3x. Then add the constants, right? Add the 4 and the minus 16, which is minus 12. Then put them all together and you got 5x squared plus 3x minus 12, right? So this is a trinomial, right? So it's got 3 different terms in it. Make sense?
mm-hmm.
Okay. Same idea with this one. We're just adding the like terms. That's all that's doing there. Okay, we'll go on to the other on the next page to subtract. Okay, and this one we're just subtracting, okay? the subtracting sign in front of this parenthesis changes the sign of everything within the parenthesis, right?
Mm-hmm.
Don't forget that. And then it's just a matter of, and at that point, you're just adding the like terms. You're just, even though it says subtracting them, you're just going to add them. Does that make sense to everyone?
Yep.
Okay, you all got that. Okay, so I won't put it on my board. Okay, so now we're going to look at the next page. Okay. Share. Okay, problems to do. And again, I really emphasize do those problems, okay? Okay, and we'll do some of them together. So add the following polynomials. Here we're just adding. So look at number one. Tell me what the answer is going to be to number one.
Number one.
You have two different terms, right?
Mhm.
So Rachel, can you tell me what the answer to number one is going to be?
I don't know. Sorry, I'm still looking at it.
Okay, okay. Do we want to do it together?
Yeah.
Let's do it together. So I don't want to. I want to make sure you all understand it. So okay. That annoying feedback is not good. Okay, here we go. So it's 3x.
Plus 4.
It's oh,
Oh, you-
okay, I see. Yeah, I'm trying to see what I, and this is, it was in parentheses, right? Not that,
Right.
Yeah. It wasn't.
okay. And then we're adding 2x, right?
2x plus 2.
2. So the first thing you want to do is get rid of the parentheses,
Mhm.
okay? And just to make, so then it becomes 3x plus 4. 2 times everything in that parenthesis is still going to be the same power, so it's going to be 2x, whoops, sorry, plus 2x plus 2, right? So now
Right.
you're just back at adding the like terms, right? You're going to add this to this, you're going to add this to this, right? Right? What's 3x plus 2x?
5x
5x.
plus
And what's 4 plus 2?
6 plus 6.
6, right? So you end up with a polynomial, it's a polynomial with two terms, right?
So why do they even, I'm sure there's a reason
Mm-hmm.
that they have the parentheses in there when you just end up
Well, it's a
getting
good,
rid of.
no, it's a good question. Just because you have,
Yeah, yeah, I was,
there might be, I mean, this is just an
yeah, that might
example.
be a 2,
This
you
2x
know,
plus
like,
2
um,
could represent something. And so
yeah, yeah.
you're adding that whole something there, and that whole something is within the parentheses is 2x plus 2. So the first thing you got to do, you got to get rid of those parentheses, and then go ahead and add them or subtract them. So right over here, if I had like, just so you drive home this point, minus 2x. 2. So if I had it like that, again, I'd want to get rid of the parentheses. So I'd put 3x plus 4. Then you look at this, this is a minus,
Oh, yeah, so it'd
like a
be,
minus 1 times 2x plus 2. So we know that a minus and a plus multiplied together is a minus. So this,
yeah, okay.
right?
Well, I figured, I just wondering why.
Yeah, it's, I mean, there's no, it just depends on what this thing stands for, that's all. And
Yeah,
so sometimes, you know, that there's no other really good reason other than
Yeah.
that. But the point is you want to get rid of those parentheses, then go ahead, clear them, and then add the like term, right? Don't make it any more confusing than that. Just, that's a simple way of doing it. Okay? Okay, stop sharing that. We'll go back and look at the other problems. Okay. Any other, what other number do you want me to look at on 1 through 10?
Oh, let's do. Why don't you do 10?
10, I knew you'd say that.
You do
Okay,
it to us.
right, I understand. That's fair. Okay, let me do it here.
Oh,
Okay. So 10, so we've got parenthesis minus a squared plus x squared plus x. No, minus x. Looking at the wrong one. Or it's a's, they're all a's, sorry. Yeah, a hard time looking at this. So it's minus a squared minus plus, that's a minus, jeepers. Minus a squared minus a minus 4. And then plus minus a squared minus a squared minus a minus 5. And then let's get this right. So do I have that correct now? A squared minus a squared minus a minus 4 plus a squared minus a. Okay, first thing you want to get rid of the parenthesis, rewrite it, minus a. Oh, Lord, this is like I'm finding my deals here. A minus a 4. Dog's excited.
yeah. Every time somebody comes in the door.
Times a squared minus a squared minus a minus 5. Now, do I have everything?
Yeah.
Okay, so it's just a longer one, that's all.
Yeah.
Again, get your like terms together. You got that one, you got that one. You got that one, right?
Mhm.
And you've got this one. You got 4 that are all a squared, right? Plus that one, right?
Yep.
Okay. And then you've got 1a, 2 a's actually, that one. And then you've got 2 constants, right? So those are the ones you want to add up together because they're like terms, right? That's the whole definition of like terms. So we've got minus a squared, that's minus 2a squared. Got another a squared, so that's minus 3a squared. One more, so it's minus 4a squared, right?
Yep.
Okay, so that takes care of those 4 little terms. And the next one, you've got an a minus a, and a minus a. So that's minus 2a, right? And then last, you've got your constants. You got a minus 4 and a minus 5, so it's minus 9. So that ends up being your simplified version, right?
Yep.
That makes sense? So if you just do it methodically and don't leave out any terms, you'll get it. Again, the first key is get rid of those brackets. Whatever they mean, just get rid of them. So then you can see the whole expression. Okay? That's how you do that. That makes sense?
Yep.
Everyone understand that? Okay, so that was, and then subtracting obviously is the same thing. When you remove the brackets, it's going to be the negative times whatever's inside, and change them accordingly. Then go ahead and add them, right? Okay, choose the one best answer to each equation. Look at number 21. What's the sum of the polynomials? Again, it's the same idea. Can we just do this without
Yeah.
my whiteboard here? So you've got an x, y, so you've got a 2xy and a 2xy, so it's going to be 4xy. So it's either A or B, right? That's the first thing it tells you. And the second thing is xy squared. This cancels this one out, the 3y squared, and so the minus 4x squared y, minus 4x squared y, added to that's going to be x squared, just one x squared y. So it's going to be A,
Mhm.
right? That's how you do that. Does that make sense?
Yep.
You just go through and just, methodically add them up or subtract them, whatever you're doing. But if there's two numbers added together, they're opposite signs, you're essentially subtracting the small one from the big one, taking the sign of the big one, right? That's the rule when you're subtracting. Um, anyway, okay, so that's how you do that. So I'm going to stop sharing and we'll move on to the next section. And you see, this lesson today is much lighter than we've done in the past. Okay, so now simplifying polynomials with more than one variable. Well, it's really what we've been doing. I mean, it's the same thing, right? We're just like I say, we're collecting like terms. That's all we're doing in this whole thing. And then down here, subtracting more than one variable. Again, you get rid of those brackets, change the sign, and then go ahead and add them all up, right? That's all we're doing in those. Let's look at the problems on that one. Again, if I was designing this course again, I would have changed some of this around. I apologize because this ends up being a light day for sure. Okay, so again, these are just doing the math with it. Anyone you want me to do? It's just work is all it is, right? I can't make it simple because you can make it fun, but it's not. Just anyone you want me to do of these. Everything I have highlighted in yellow, you can see, or that's what's assigned. Okay, that should be in your homework list. And the 1 through 8 they don't have any brackets at all, so you're just simplifying every 9 through 16. You're adding something within a bracket, and so the first thing you want to do is get rid of that bracket, and then go ahead and add them, or subtract them accordingly. And then down here it's the same thing, adding and subtracting. And some of they may look a little scary to you, I don't know, but it's just a matter of doing the math. What if we do 23? Let's do 23, okay? It looks a little challenging. Again, 23 is c to the cube, third power, d to the seventh power. Plus c squared minus d plus 35. And this whole thing, there's brackets around this whole thing. All right. This one we're subtracting the second polynomial, c, or 2, excuse me. Yeah, sorry. Subtracting 2c to the second power minus 3 d plus 35, right? So it looks like that, right? Again, the first thing we want to do is get rid of those brackets. So it becomes C cubed D to the 7th power plus C squared times D plus 35. Now, it's going to be minus 2C to the 2nd power. Shoot, that equal sign should have been a negative, okay? I can't change it now. I just
Oh,
won't let me do that, but so assume it's a negative. So you've got a negative times a negative. So it's a positive. And it's positive 3. It's positive 3, not 2. And then it's negative 35. Okay. So that's what it looks like. So the next thing you want to do is combine your like terms. And I like to do it like this. C cubed, that's all by itself. This you can combine with that. The D with that, and then the constant like that, right? So that's what you have to work with. So, since you only have C to the cube D to the 7th power all by itself, so that remains like that, right? So, this annoying thing here. D to the 7th power. And what's C squared minus 2C squared equal to?
uh, 1.
And what's
Negative.
negative 1? Thank you. So it's negative C squared, right? And what's minus D plus 3D equal to?
2D.
Plus 2D, right? And what's 35 minus 35 equal to?
0.
0. So you don't put that down. So this ends up being the simplified version, right? It should be a 3 here. Sorry. Again, it won't let me. Since I've already stopped it, I can't fix it. It should be C to the cube D to the 7th, right? You understand what I mean on that?
Yeah.
It's like this. Like that.
Oh, shit. Multiply.
Matter.
Christ.
So that would be your answer. C cubed D to the 7th, that's one term, minus 2C squared plus 2D. Okay. Okay, so anything, let's look at the rest of that. Okay, any more on this page? Okay. Okay, so there's just those two sections. So I think what I'm going to do now, we're going to go back and look at, just make sure you understand what we went through on last Wednesday. We did a lot, right?
Yes, please do that.
So I want to, so let's go back and look at absolute values and let's work our way through. I think it's important. I really want you to understand it. So let me go ahead and find, I'm gonna go back here, back to week 5, the 28th. Sharing and
It
share.
was lesson 4 through
It's lesson,
9?
no, lesson 5 through 9,
9. Okay.
right? Or 5 through 8.
5 through 8.
But yeah, it's 5 through 8, but that's a lot of stuff.
Yeah.
Talk about absolute values. Do you understand the concept of absolute values? Well, let's
Yeah.
look at the next page because it'll have some problems there. And that's going to be on your quiz in another hour from now. So it's important that you understand it. And you can use notes on your quiz. I want you to feel free to do that, okay? So, absolute value, everything you want to know about absolute value is right here. All the questions. Let's look at a number like, look at number 13. What would that be equal to? 5 plus the absolute value of minus 6.
It'd be 11.
It would be 11, right? Because this minus 6, the absolute value of any negative is just a positive, right? It's the magnitude of that thing. That magnitude is always positive, so it's positive. So it's 5 plus 6 is 11. Boom, that's simple. What about number 17? You've got absolute value of 110 minus 201. What's 201 minus 110? I'll tell you, it's negative 91, right? That's what it is. So what's the absolute value of negative 91?
Positive 91.
Positive 91. Now you've got a negative on the outside of this, right?
Makes
So
it
what's the final result going to be?
negative 91.
Exactly, it's going to be negative 91. That's the answer, right? What about number 21 here?
21.
What you've got a negative 5 times negative 4 in absolute value of.
Okay, then it is negative 20.
It'd be negative
Because
20. Is
negative
that,
negative 5, right? Yeah.
people understand that? Okay, silence is consent, I guess, on that one. Okay. What about number 14?
14. It's going to be a negative whatever 52 times 3 is.
Well, wait. Why is it going to be negative?
Because of a negative 3. Oh, I'm on the wrong one. Sorry.
That's okay. So number 15.
15. Oh, it's going to be positive times.
So it'd be, yeah, it'd be 156. So be positive 156, right? So you see how to do these, right? Now, let's look at 20. I'm going to write it down and go to my board here. Okay, right. Just a minute. -7, negative. Okay, I'm going to look at 20. So stop sharing, share, doom. Rid of this. Okay, negative or 20 says 49 divided by, I don't have that sign, divided by negative, oops, and this is where I hit -7. So it looks like that, right? Well, not exactly like that. Just a minute. Let's deal like that. It looks like that, I think. 49 divided by, in parentheses, a negative absolute value of -7, right?
Mhm.
You got to do this thing in steps. So it's going to be 49 on top. I'll just put my divider sign here now. Divided by what's negative times an absolute value of -7 equal to?
That is going to be a negative 7. It's going to remain a negative 7, right?
It's going to end up a -7, right? Is what you're saying.
Yep.
Right? Because the -7 is going to be positive times the negative is going to be negative, right? Does that make sense?
Mm-hmm.
And then what's 49 divided by a -7 equal to? Knowing that the 7 is a perfect square for 49,
Be negative 7.
it'd be -7. Okay, you understand that? That's how you do these, all these negative. What if we had If you get something like that, you got 31 minus 33, all in absolute value signs, times -2. What's that going to be equal to?
What is it?
You've got 30 an absolute value of 31 minus 33.
It's gonna be 2. Isn't it?
But no, not 2. It's close, but
Well, I
what's
mean that first part.
what's the 30? Oh, okay, it's going to be
Yeah.
a 2. You're right.
Yeah.
Then times, well, we're timesing by a -2, right? So what's
Negative,
the end result?
-4.
Does that make everyone understand that? Okay, you should understand this for absolute values. Yeah, at this point, I think if you can understand that, then you can do all these that are given here. Okay, so I'm gonna stop sharing that. Let's go on to the next section. Okay. I'm going 2 more over into, do like this. I went over by, okay. Oh, these ones. Remember how to do these. Converting algebraic expressions, writing algebraic expression for each description, turning from a description to an algebraic expression. Some of these get a little tricky, right? If you see something with a product in it, that means multiplying. So a product of 8 and a number less than 10. Whenever you say number in here, just replace that number, that it's a variable, with X. So this one here, a product of 3, or excuse me, the product of 8 and a number less than 10. So a number less than 10 would be X minus 10. That would be a number X less than 10. It's a product of 8, so it's 8 times X minus 10. Right? So you write it like this. So you'd write it like this. You'd say 8 times a number less than 10. Like that, right? But now we want to simplify that, right? So now we can multiply the 8 times X and 8 times minus 10. So what's the simplified version of 8 times X minus 10?
8x times what? Yeah, 8x minus 80.
Yep, that would be the answer. Okay. Does that make sense? Anybody? Oh, Lucero, I'm glad you're there. I now see you. I see that I can't see you, but you're there, I know. Okay, so I'm going to stop sharing that. I mean, there's one of these on the quiz, and it's not a hard one. I don't think it's a hard one. Let's look at number 11. A number less than the sum of another number and 13. So now we've got 2 variables, right? We got a number. So how would you write that one?
Which one is it?
Number 11.
11. A number less than a sum.
A number less than the sum of another number and 13.
It would be x.
Yep.
Minus.
Yep.
What?
The sum of another number. So call that other number like y, right?
Yeah. I'll get this first.
So how could you write that?
Thing.
What would you do?
X
Yep.
minus y.
Well, that's part of it, but it's not only y, it's the other number and 13.
Yeah, and then add the.
But here's how you would write. Okay, I mean you got the idea, but I think the signs are not quite right here. Here's how you would do it. So I'm gonna stop.
Yeah, be x minus y plus 13.
Yes, but tell me where the brackets are. That's
on the X and the Y.
Well, it's
Or the
like,
Y.
it's like this. Can you see my screen?
Gotcha. Yeah.
Right? It's this, it's a number minus a number plus 13, so that it's minus y plus 13. That's that part of the expression. And then you simplify that by saying x minus y minus 13, right?
Mhm.
Does that make sense?
Yeah.
That's the simplified version. Okay. Okay, I'll stop sharing that. Okay, we're gonna go on to the next section. I mean, we really did a lot of stuff on that day. I mean, there was just too much, I think, but anyway, hindsight's better than foresight. But okay, so now we're just simplifying things, and we've simplified. We know how to simplify. Look at number 3. How would we do this one? This is order of operations, right? That's what we're doing here. So number 3, how do you do that?
Minus 6x. 3x minus 6x. What is 6 times 9? 50 something?
It's 54. So
Yeah.
again, just a minute. I'm going to just do it on the board here. So this is number 3 on page 331. So it looks like this. Share. So it was 3x minus times 6x, right? Minus 9. It looks like that. So what we want to do is we want to, oh no, there's 6 on the outside. Sorry.
Mhm.
Yeah, just that. Like this. Yeah, it's like that, right? So what we want to do is multiply that negative 6 times what's in the bracket here. So it becomes 3x minus 6x, right?
Plus 54.
And minus 6 times minus 9 is plus 54, yes. So it looks like that, and then you just combine the like terms, and you've got a negative 3 and a positive 3x and a negative 6x. So it's negative 3x, right? Okay, so that ends up being your answer. That makes sense? That's how you do those. If there's anything else complicated on that. How about number 13? Could you do number 13?
13 is x plus 1 squared over 2 minus 10.
Does anybody?
Would it be x squared plus y squared over 2 minus 10?
I don't know yet. Just doesn't sound.
I want to say. And then x4.
Minus
Okay.
2 minus 10. All right. So it looks like that. You've got an x and a y, and so x is equal to 2, y is equal to 4. So that's just 2 plus 4, right, within brackets. And you're squaring that, and then you're dividing the whole thing by 2, and then you're subtracting 10.
So it's
You know, so then you combine the 2 and the 4, you get 6, right? So it's 6 squared divided by 2. So it becomes 6 squared divided by 2 minus 10, right?
8?
I don't know yet. So now it's 6 squared is 36
Mhm.
divided by 2 minus 10, right? 36, yes, 36 divided by 2 is 18 minus 10. And the answer is equal to 8. Boom. Okay?
Hmm.
That's how you do that. Okay? So who said 8?
I did.
Okay, good job. Okay. That's what it's equal to. So that's how you do it. Okay. I'm gonna go 2 more down. Okay. We didn't even get into the prime factorization of anything, did we? But we did. No, but I mean, a factor is just a number times another number. It's just a way of breaking it up, right? The prime factorization of 6. How do you make 6? Well, it's 2 times 3 is 6, right? So those are the prime factors of 6. 21, how do you make that? It's a 7 and a 3 is 21. Those are prime factors. 7 is a prime factor, is a prime number, and 3 is a prime number. Do you all understand what a prime number is? Do you know? I'm just gonna really quick. Prime number is anything that can be multiplied by or divided by itself or 1. In other words, 1 would be a prime factor. 2 would be a prime factor. 3 would be a prime factor. 4 would not, because you can divide it by 2 and 1. 5 would be a prime factor. 6 would not, because you can divide it by a 2 and a 3. 7 would be a prime factor. 8 is not, because you can divide it by a 4 and a 2. 9 is not, can divide it by a 3. 10 is not, you can divide it by a 5. As you can just see these prime numbers here, you can divide it by 1 and another prime number. It's not a prime factor. 11 would be 1. 12, you can divide it by 2 and 3. 13 would be 1. 14 divided by 7 and 2. 15 divided by 5 and 3. 16, 8 and 2. 19 would be 1. These are all prime numbers, okay? 20 is not, because you can divide it by 5 and 4. 21 is not, you can divide by 7 and 3. 22 is not, you can divide by 11 and 2. 23 is 1, right? 24 is not, because you can divide it by 4 and 6. 25 is not. 26, you think 26 is, you can divide it by anything? What about 26?
Oh, it's 13, isn't it?
Exactly. So you can't put it down. Exactly right. 27, what about that? Can you divide that by anything up there?
Yeah, the 7.
Yeah,
No, I'm sorry.
exactly. 7 and exactly. 7 and 9. Well, we don't have 9 up there, but because it's 3. 27, 28. What about that one?
I don't
It's 7.
see
You can
it.
divide by 7, right?
Now I
What
see
about-
it.
Right? What about 29? Can you divide that by anything up there? No. Right. 30 divided by 5. 31. No. 32. You can divide it by an 8 and a 4 and a 2. So anyway, factors. 33. Yeah, 33. No, because you divide by 11, right? 34. You see how to do this? 35, 36, 37. 37 would be 1. One of my classes, I had everybody put these down all the way up to 40. Just
Why
roll.
can't you do it for us here? And then we
Well, I
can-
started doing it for you as you were doing it, right? 38, no. 39, no. 40, no. So this is, and then 41 would be another one. But this would be up to 40. These would be all the prime numbers there are, right?
I never knew what that was before.
Well, now you know.
Oh, yeah.
It's just it's used in factorization. That's why it's important. prime numbers are unique in that they can only divide it by itself and 1. That's the definition of a prime number. Anything that's not a prime number, I can't remember, it's a normal number, or it's just a number, right? But there's prime numbers and, you know, and none of them are negative too. They're all positive numbers, right? But that's a prime number. Okay. And we use this because factoring becomes important. Like all the other numbers can be a factor of 1 plus one of these numbers. That's what makes it a prime number. And that's why it's important when we're reducing numbers down by factoring. That's why you use factoring. Okay. It's all related. Okay. Okay. So that's what that's all about. Okay. So it's important. It really is. And anyway, let's go on to the next page.
Mm.
Again, this it covers a lot of material. I know. Okay. Yeah. Okay. This is just how to use algebra. I mean, just if you know your variable, you just plug that variable value into the expression and solve for the expression. That's all we're doing here, right? But look at like number 2, find the value of 7x. This is the square root of 7x plus 2x to the nearest 10th when x is 5. How do you do this one?
You put 7 times 5.
Yeah,
Square root
yeah,
of 7 times
yeah.
5 plus
And
2
then,
times.
yeah, and plus, yeah, 2 plus 2 times 5 or 10, right?
Mhm.
So you get your calculator and you say, what's the square root of 35? So you should be able to do that on your calculator. Can everybody do that? See if you get the right answer. You remember how?
Yeah,
We want the square root of 35. So it's x squared, but it's the radical above it, that little radical. That's what that is, the square root. So you have to hit the second button first, then hit x squared. Now you're down to the radical. And then put in your number like 35, hit enter, and you should get, what's everyone get when they do that?
like,
Did
what was it?
anyone
Like
get that?
15.9
Oh, yeah,
and then
yeah,
back to
right. It'd be that 35, the square root of 35 is 5.916, keeps on going. And then you add 10 to it. So it's 15.916. And we're asking it to the nearest 10th. So what's that answer to the nearest 10th?
15.9.
15.9. Exactly, because the one number to the right of that 9 is 1. So you leave the 9 alone, so it comes 15.9, right? That's how you do that. Okay. Any others on that page that look intimidating? Do you want me to do?
Which one did I have issues on?
We're on
15.
page 15, okay. If x is equal to 20, what's the value of the expression 4x plus 7? So let me write it down here. 4x plus 7 minus 3, x minus 2, x plus 7. Okay, so let me go to our right whiteboard here. Okay. New. Okay, so we have the expression 4 times x plus 7 minus 3 times x minus 2 And we're asked to find when, okay. And x is equal to 20, right?
Mhm.
Okay. So the first thing is put substitute. Just leave a bracket, just put it where it belongs. Right? Okay, that's the first thing you do. You put x is equal to 20 into that expression where it belongs. And then you combine everything within the brackets, and then you do your final step. So it becomes 4 times 27, right? Minus 3 times 7 times 18, right? Now it's just a matter of doing the math on it. 4 times 27, 4 times 30 would be 120, minus 12, so it'd be 108. Right? You do it on the calculator, that's what it is. And 3 times 18 is just 54, right? It's 54. Yeah, the way I do it, I just look at 3 times 18 and say, well, it's like 3 times 20, and then I subtract 6 from it, and I get 54. So it looks like that. So now it's 108 minus 54. What's 108 minus 54?
54.
54, very good, very good. That ends up being your answer, right? That's how you do that. Questions on that?
On that.
Don't try to do extra, don't try to double up on steps. Just do
You
it
say
in one.
108 minus 54 equals 54?
Yeah, yeah.
Oh, okay.
It's 54 and 54 is 108, right?
Right.
Okay. So that's how you do that. Okay. Okay.
It hurts.
Okay, I'm gonna stop sharing that one and we'll go on to the, I think it's the last one here. Sharing. Oh, okay, this is, okay. Identifying terms, whether it's a monomial, I have a hard time saying that, binomial or trinomial. So what about 1? What is that?
Monomial.
Monomial, right? And what about 2?
What is it? Trinomial, because there's 3, right?
No, no, just caught you on that. No, it's just 1. It's just one term.
Oh,
So it's still a monomial. Okay. What about number 3?
now you got me confused. Binomial?
It's a binomial, right? Well, that's what we're going over them a little bit. What about number 4? The dog's got the answer. No.
Trinomial.
Trinomial, right? And what about number 6?
I want to see trinomial again.
Yeah, trinomial, right? What about number 7?
Monomial.
That's just a monomial, right? It's just 1/3 times x. So, you know, the 3 is like the coefficient times that. So what about number 9?
Ooh. God.
Don't be confused. Don't let it confuse you.
I'm confused.
It's just one big term, right? It's just got number of variables.
Got it.
So it's monomial.
Very
That's all.
intimidating.
Right? Right? And what about number 14?
It is 1.
Just
Monomial.
1. And so it's monomial, right? And what's the square root of 49?
7.
7, exactly. It's a perfect square, right? Okay, look at for each monomial terms of don't worry about that. Remember that well, yeah, they're all just terms, right? That's sort of a stupid problem or question. They're all different. Well, I guess they're not. Okay, so look at 27. How many terms do you have? Let's see what we've done.
2.
2, exactly. So because 18y squared minus 4y squared is the same term. Yeah, exactly. Okay. Choose one best. What is the sum of the exponents in the expression? What's the sum of the exponents in the expression? Okay, what that means is we're just adding the 3 and the 2 together because they're both exponents, so it's 5. But anyway, I don't know. It doesn't really tell you much. Okay, so that's a really a quick review of what we did on Wednesday. We're going to take a 15-minute break, or a 10-minute break, excuse me. Up to 9:30, we'll come back and I'll introduce the quiz to you, okay? So take a break. Thank you.
Gotta go potty. Go potty. Come on, let's go potty, Ronnie. Let's go potty.
Okay, so yeah.